Hello and welcome to Lecture 9, wherein we discuss the for loop and the do-while loop. For your reading assignment, consider reading the first half or so of Chapter 4, which is to say 4.1 through 4.5. You've already covered the second half of Chapter 4, which talks about the switch statement and logical operators. So by the end of this lecture, you should be pretty much ready to go with the entirety of Chapter 4, and you can handle the practice exercises at the end of the chapter. Today, we're going to talk very briefly about counter-controlled repetition, both with the while loop and with the for loop. We'll talk about the for loop, since that's a structure we haven't yet used. I'll show you a couple of variations on the for loops. There are some ways that we can mess with it that you might see on an exam, or that you might see particularly bad or obnoxious programmers use in the real world. We'll talk about sentinel-controlled repetition, which you've already done with the while loop. And then I'll show you how to use the do-while loop to validate input. Finally, there will be some concluding notes and a little bit of wrap-up. So counter-controlled repetition. This is a repetition that we've already done. Involves using a loop to perform a certain set of actions a certain number of times. And maybe we know that certain number of times already. Maybe it's a thing that our program figures out on the fly. Maybe it's a thing that we ask the user of. And we keep track of all that, of how many times we've gone through the set of actions with a counter. And so in order to do this, we need a counter properly initialized. Usually you'll initialize this to 0 or 1, but that's not always the case. We need an end value. We need to know when to stop. We need a condition that ends the loop when the counter reaches that end value, and also a condition that will keep the loop from happening while the counter is outside of a certain range. Then we also need to increment and decrement the loop counter appropriately for each iteration. And with a while loop, that looks something like this. We create our counter. We have an end value. We end as soon as I is equal to or greater than 15. In this case, it'll be equal to because of the way this is structured. We have our conditional. We keep looping only so long as I is less than 15. And then we have our counter increment. We increase this by 1 every pass through the loop. And of course, we also have our loop body, that system.print line I times I. This will just print out the perfect squares between 0 and 14 squared, which is 196. But this isn't the only way that we might do such things. Okay, so let's take a look real fast at this particular loop structure. And we have this here. This is a very, very simple loop. We create our counter. We loop so long as the counter is less than 15, and every time we loop, we increase the counter by 1, and we output in some order. Sometimes it'll matter which way you do it. This time it doesn't particularly matter, and you can output in any of a variety of ways. Then we end our program. And as before, this loop right here is going to execute as long as the condition that I is less than 15 is true, which in this case will print out the first 15 perfect squares to the screen. So let's take a look at this in action. We'll compile, and then we'll run. And we should get, at this counter-controlled loops with while, we get the first 15 perfect squares. That's 1, 4, 9, 16. This is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And the way that we're getting this is, if we look back at our code, we're just getting 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and so on. So it's not too bad. Now one of the problems, and I say a problem, I mean this is not a problem with Java itself, but a problem with users, more specifically a problem with us as programmers, is that when we build counter-controlled loops like this, it's really easy for us to, for example, forget to create a counter, or to forget to do that incrementing. A good number of you have already run into the infinite loop problem, wherein we just forget to increment. That's okay. It doesn't make you a bad person. It just means you have to have your increment or your decrement, as the case may be. Java has a built-in loop structure for counter-controlled loops, and that's called the for loop. The for loop is just for when you know, or when you can figure out how many times you should go through a certain process. And the cool thing about the for loop is that if you write the for loop the way that it's meant to be written, as opposed to using any of the slightly wackier variations that we'll talk about in a bit, it'll it sets up a system by which it's much harder to make mistakes with writing counter-controlled repetition, which is to say that there's a spot for the scoped counter. We'll talk about scope next week, and there's also a spot for the variable incrementing or decrementing, as the case may be. Here's what a for loop looks like. You've got the for keyword, a whole bunch of stuff in some parentheses, and then a loop body. And we'll go through this the stuff in parentheses kind of iteration by iteration here in just a second. The first thing that we have is we create and initialize a counter variable. So this first space, as demarcated by this semicolon and that semicolon, that first space happens as soon as we enter the for loop. We create and initialize a variable. The second thing that we have is our condition. Okay, in this case that I is less than 15, so we keep looping so long as that condition is true. The condition gets evaluated at the beginning of each pass through the loop. And then finally, we have our increment or our decrement, as the case may be, which is done at the end of each pass through the loop. Okay, so at the very end of the loop body, we just have this sort of sneaky I++. So those are the three things that we have. And those are separated by those two semicolons. And the two semicolons are important. You can't have more than two semicolons. You can't have fewer than two semicolons. You have to have exactly two inside your loop, your for loop declaration. But again, we've got our counter, which we create as soon as the loop starts, our condition, which we check at the start of each iteration through the loop, at the start of each pass through the loop, and then our increment. And the really cool thing about the for loop is that we can accomplish, using slightly fewer lines, the same thing that the while loop does with regard to counter-controlled repetition. So the for loop is just a tiny bit more compact, and again, the really, really nice thing is not necessarily the compactness, but because of the way that the syntax of the for loop requires that we have our counter, increment or decrement at the end, and then our variable initialization declaration at the beginning, declare then initialize, and then also certainly the conditional. If you write a for loop correctly and it compiles, then you've probably got a counter-controlled loop that at least mostly works. There might or might not be logic errors with regard to how you wrote the loop, but certainly it'll compile and Java will run it. Okay. And that's the really nice thing about the for loop. It helps keep us from making certain types of mistakes. So let's take a look real fast at our first for loop. Okay, and so this particular line, this particular set of conditions will print out starting with 1 squared and going all the way to, in this case, 14 squared, but let's make that 15 squared. All the perfect squares, each on their own line, just slightly more compact. It's going to do basically the same thing that the last program did. And you can see with this for loop basics, we have all the way through 225 output to the screen. And most of that magic comes from our for loop itself. This is just a different structure, a different way to write your loops. It isn't anything that you need to worry too terribly much about. When we come back, we'll talk about the for loop variations. There are 4 different ways, well, there are 3 different ways that you can modify the way that you write your for loop. All of these ways are sort of obnoxious, which is to say that I'm going to suggest that you don't do them. But we'll come back and we'll talk about that here in just a second. I'll see you in a bit.